Hello students, welcome to the channel. A bird's eye view of the chapter motion. Thus far we have already covered distance, displacement, scalars, vector, uniform, non-uniform speeds, velocities and so on in the previous episodes. Today we will be concentrating on non-uniform type of motion, which is also known as accelerated motion. That is when the speed or velocity they are changing with respect to time. Accelerated motion, this is a bird's eye view of the topic which I am giving you, can be further divided into types. Say acceleration can be positive, negative, can be uniform, can be non-uniform. And for all these cases, we can of course find average and instantaneous acceleration. But let me tell you, basically in this chapter of uniform of motion in 1D, we will be specifically concentrating on uniform acceleration only. But even though I will give you a little glimpse of non-uniform acceleration. So you might be thinking, what is acceleration, or how can we actually define it? How can we calculate it? And so many other things may be coming into your mind. So let's, without wasting time, get on to the topic acceleration. Let us consider three different situations. We are in a phase of understanding acceleration. Suppose in the first situation you consider a car moving at a speed of 60 kilometers per hour. Second situation, train moving at 120 kilometers per hour constantly, and a plane moving at a speed of 1000 kilometers per hour constantly. Now what do you have to say about this situation? Is it accelerating? Is the car accelerating? You may wonder, we haven't studied acceleration yet, or you may think we have studied it in class 9, but I would like you to put up your opinion whether this car is accelerating. We have to use sometimes our intuitive knowledge. We haven't defined acceleration yet, and we haven't told how to calculate it. But still, intuitively, you know, here the car is moving at a constant speed of 60 kilometers per hour. So the acceleration comes out to be 0, or better to say, it is not accelerating. Same is the case with train. Even though the speed is more, but still you will say that the acceleration is 0, or it is not accelerating. And if I consider the plane, then also you have to agree that it is also not accelerating. So the acceleration is 0 in all these three situations. What are we trying to conclude? We are trying to conclude at the same time we are trying to dislodge the very common opinion that sometimes acceleration is associated to high speed, which is not correct. Acceleration has nothing to do. Whenever you hear this term, no, you have to accelerate the bike, accelerate the scooter, accelerate the car. That means it gives us an idea that we are talking about high speed. Even though I may talk about a very high speed of 1000 kilometers or 120 or 60. High speed has nothing to do with acceleration. Acceleration is not an idea of giving you understanding about only high speed. So what do we conclude? Why have you said there is no acceleration? Yes, because you don't see any change in the velocity. In all these three situations, whether the speed is small or large, it is constant. So what have we concluded? This is our important conclusion. Acceleration exists when velocity changes. Acceleration exists when velocity changes. Now what is velocity? It is nothing but speed plus direction. This is something we expect you to keep in mind. So acceleration exists when velocity changes, and acceleration is not exactly high speed. Even though we can talk about a high speed, still the acceleration may be 0. Now let us quickly see two situations. A body is moving from A to B with a constant velocity of 20 meters per second. Again, what is the idea about acceleration? Acceleration is 0, or you can say this body is not accelerating. Why? Because magnitude of speed remains constant, at the same time velocity is also constant, it is not changing its direction. Consider this situation. Suppose a body is moving from point A and it has started its motion in the direction of the arrows, and then like this, and then like this, and then like this, and then like this, with the same speed, 20 meters per second. Now what do you have to say? Is it accelerating? Even though the magnitude of speed remains constant, 20 meters per second throughout the journey, is it accelerating? Yes, the answer is it is accelerating. This is the case of acceleration. Why? Even though the magnitude of speed is 20 meters per second constant, but what is changing here is very evident from the picture, that the direction of arrows are indicating that the direction of motion is changing. Therefore, you say it is accelerating. Yes, what is constant here? Yes, here the speed is constant. You can say the magnitude of speed is constant, but velocity is changing. In this situation, velocity and speed both are constant. So we have come to a place, we have talked much about this word acceleration. Now we are in a point, what is acceleration? The definition, and once you know the definition, how to calculate acceleration. Can you see this diagram indicating the change in speed as well as change in the direction of motion, and a small simulation to give you an idea how the body changes its velocity as well as direction and speed. Yes, so let's move on to the understanding or definition of acceleration. What is the definition of acceleration? So, it is rate of change of velocity. The rate at which velocity is changing, or the change in velocity with respect to time. So here our keyword is rate of change of velocity. Mathematically, we write acceleration as change in velocity upon change in time. So what is V? Here V represents final velocity. This is final velocity. What is U representing? It is representing initial velocity. So final minus initial is nothing but change in velocity. And this is the time interval. This is representing final minus initial time or time interval. So mathematically, acceleration is change in velocity upon time. How to find change? It is by taking out the difference between the final and the initial values. SI unit of acceleration. From the mathematical expression itself, we can get, initially in the numerator, we have to write the SI units for velocity. So what are the SI units for velocity? It is meter upon second. And in the denominator, I have to write the units for time. So it is S. What am I getting? More decently, it looks better if we write meter per second square. So what is the SI unit of acceleration? It is meter per second square. Meter per second, this represents velocity. Upon time, this is for seconds. So we have meter per second square. What type of quantity is it? Of course, a vector quantity, because there is some speed, magnitude of value as well as direction associated with it. Average acceleration over a complete duration. Sometimes the velocity increases, sometimes the velocity decreases. Overall, what is the in overall span? What is the change? Average acceleration is change in velocity upon the time interval. And instantaneous acceleration, at any particular instant, acceleration at a particular instant can be derived when you take limits. Delta t tends to 0. That means when the time interval becomes so small that it almost approaches 0, then your delta t tends to 0, delta v by delta t becomes dv by dt. This we have already seen when we were studying calculus. So delta v by delta t, big change in v upon big change in t becomes small change in v upon small change in t. dv by dt, rate of change of velocity with respect to time, or we can write it as d square x upon dt square. Second order differentiation of position with respect to time, because velocity is already dx by dt and differentiation of velocity is d square x by dt square. Acceleration can be positive. If your final velocity is greater than initial velocity, you will get positive acceleration. If your final velocity is less than initial velocity, the acceleration will be negative. The value you get will be negative. We can see a small numerical with a graph on this particular aspect. Acceleration can be uniform and non-uniform. Uniformly accelerated motion. It is defined as acceleration is constant or when change in velocity per unit time is constant. Like we can see an example. Velocity time tabulation. In the first 1 hour, the velocity was 50 kilometers per hour. Second hour, the velocity increased to 55 kilometers per hour. That means the change is 5 kilometers in 1 hour. Then, let us say in the third hour, the velocity increases to 60 kilometers per hour. And in the fourth hour, it changes to 65 kilometers per hour. What do you conclude? The change in velocity after every time interval is constant. From this situation to this, 50 to 55, velocity increased by 5 kilometers in 1 hour. Then 55 to 60, here again the velocity increased by 5 kilometers. Here also the velocity increased by 5 kilometers. So always the change in velocity per unit time is constant. It is 5, 5, 5, 5 only. So there is change. Velocity is not constant. Keep it in mind. Velocity is changing from 50 to 55, 55 to 60, 65. Velocity is changing, but the amount of change is constant. From here to here, it changed by 5 kilometers. Here to here, again 5. The change, the amount of change is constant per unit time. So this type of acceleration is known as uniform acceleration, where the change in velocity per unit time is constant. If we try to plot a graph for uniform acceleration, first 1 hour, second hour, third hour, fourth hour, fifth hour, the velocity in the first 1 hour is 50 kilometers. In the second hour, it goes out to 55. In the third hour, it comes out to be 60. In the fourth hour, it comes out to be 65, and so on. So what type of graph are we getting? For uniform acceleration, we are getting a straight line. If the initial velocity is known to be 0, then our graph will start from origin. But here we have mentioned nothing about the initial velocity. We are taking 50 as the initial velocity. So we are starting the graph from here. If the initial velocity is mentioned to be 0, then we can start it from the origin. Second situation, non-uniformly accelerated motion. Here again acceleration will be there, means velocity will not be constant, but the change in velocity, the amount of change per unit time is not constant. Let us see an example. Velocity time tabulation. In the first hour, the velocity is 50 kilometers per hour. In the next hour, velocity increased. But what is the amount? From here to here, everywhere the increase was by 5, 5, 5. But in this situation, it increased by 4 kilometers in 1 hour. Then in the next 1 hour, the velocity increased from 54 to 57. That means the increase is 3 kilometers per hour. Then in the third, 57 to 63, it increased to 6 kilometers per hour. Means here also there is velocity change. Here also the velocity is changing. But what is the difference? Here the velocity is changing in equal amounts or constant amount. Here the velocity is changing in variable amount. Sometimes it increased by 4, sometimes it increased by 3, sometimes it increased by 6, sometimes it may lead to decrease also. So whatever, the change in velocity per unit time is not constant. This type of acceleration is non-uniform acceleration. But in our topic or in our chapter, in our syllabus, we will be concentrating only on uniformly accelerated motion only. This is our point of interest because the syllabus has only this thing, uniformly accelerated motion. If time permits, we can see some situations of radial as well as tangential acceleration which leads to non-uniform acceleration. But if we try to plot a graph, VT graph of this situation, so it is initial 1 hour 50 kilometers, then from here it is 54 and then the change. What type of graph are we getting? Yes, of course, we are not getting a linear graph. So this is the situation where you can clearly see acceleration can be uniform and non-uniform. Can we do a small question now? Let us try to solve a question in order to apply the concepts of instantaneous and average acceleration. Let us see, it is given that velocity is given in the form of equation 10t plus 5t square. Means velocity is a function of time t. You have to find average acceleration in the time slot 0 to 2 seconds and instantaneous acceleration particularly specifically at 2 seconds. Let us begin with average acceleration. You know that it is change in velocity upon time. Change in velocity, you have to find out velocity at t equal to 0 and you have to find out velocity at t equal to 2 seconds and then you have to find the change. So let us start with this. Velocity at t equal to 0 is 0 because when I put t equal to 0 here I get 0 and here also 0. Velocity at t equal to 0 is this and velocity when time is 2 seconds. So when I put t equal to 2 seconds this becomes 20 plus this becomes 4 5s are 20. So this becomes total 40 meters per second minus 0 meters per second. Why I have taken it like this? Because it is final velocity minus initial velocity. Final velocity is when time is 2 seconds. Putting the value of t as 2 seconds, I get in both these equations, I get 40 meters per second, 10 into 2, 20 plus 4 5s are 20. Okay. And upon the time interval is 2 minus 0. What am I getting average acceleration? I am getting 40 meters upon seconds upon 2. So this gives me 2 seconds. So this gives me 20 meters per second square, which is the acceleration of average value. Now instantaneous acceleration. If I have to calculate instantaneous acceleration, what am I going to do? I have to find dv by dx. You know, it is when the limit time gap delta t becomes 0, then delta v by delta t becomes dv by dt, rate of change of velocity per unit with respect to time. So I have to differentiate the relation of v. So I am getting A instantaneous is equal to, when I differentiate it, I get 10 as a constant. Differentiation of t with respect to time is 1. We have already studied calculus. Please refer to those episodes. Plus 5 is a constant into differentiation of t square. This is in the form of x to the power n. So it becomes 2t. So what am I getting? 10 plus 5 2s are 10 t. This is the instantaneous acceleration and I have to get the value at t equal to 2 seconds. Putting the value of t equal to 2 seconds, I get 10 plus 20. This is 30. T equal to 2 seconds. If I put this 2 seconds, then I get 20 plus 10, 30 meters per second square. This is the instantaneous acceleration which I got by differentiating the expression of velocity. Average acceleration I got by putting t equal to 0 and t equal to 2 seconds and finding the change in velocity upon time. So this is how we have applied the concepts of average and instantaneous accelerations, which is very important and very important for the students to practice. A lot of questions. You can put your doubts in the comment section down below, and be healthy, be connected, brush up with the previous episodes. All the best to all of you. Thank you.